Alright, so we're now going to look at Chapter 2, Section 3, and we're going to look at measuring central tendency. And what we have to do now is we're going to have to bring our numbers back into bear for data so that we can describe our data. And I hinted before in the kind of preface to all this that there's three M's are our middles: mean, median, and mode. And what means does is mean is synonymous with average. And it's an idea of where most of our stuff is. Median is the middle. And so 50% of the data is before and 50% is after. And then the mode is the most frequent thing. And so the three M's are what we're going to look for: mean, median, and the mode. Average is where most of the stuff is. Median's in the middle with 50% ahead and 50% behind. And mode is the most frequent. Now, we're going to get some notation here that comes across. And so when I'm going to talk about the notation. So let's look at the mean. And what we're going to do is we're going to use this sigma again to say that we're going to add up. And this means we add up all the pieces of data. And so we start with the first piece of data and we go all the way to the last. And I use the little subscripts here just to tell me which number piece of data I'm looking at. Now, when I talk about populations, I tend to use Greek letters. And so the population mean gets mu, which is the Greek letter M. Kind of looks like a cursive M or a U, a mu. And it's the sum of all the data divided over every piece of data in the data set. And so again, this is a population. This means we have everything. And for a sample mean, we represent that by X with a bar over it. And that's the sum of every piece of data in the sample divided by the number of things in the sample. Now, these are not formula in the sense where you plug things in. These are formula that tell you how to calculate things. So I'm going to use an example of a sample. And the sample we have is the weight in pounds of adults that are in a weight loss study. And so the data is so this is the weight of everyone in the weight loss study. And now what I'm going to do is, this is a sample, and so I'm going to use a sample mean. And so what I want to find is X bar. And to do that, I need to know N, or how many pieces of data there are. And so there's 1, 2, 3, 4, 5, 6, 7 pieces of data. And what I do is I add up all of the X's. That's what this notation is telling me to do. The sigma says add up all of the X's and then divide the answer by N. And so run over to my calculator and adding up 274 plus 235. So I'll do the sigma of xi equals 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235. And I type that in, and I get 1,810. But to find X bar, I need sigma xi, or the sum of all the x's, divided by n, which is 1810 divided by 7. See if I can type properly today. And that is 258 258.571428 and so on, because calculators give me extra digits. And so I'm going to use a wiggly line to say I'm going to approximate. I'm going to round to one decimal place, and that's 258.6 pounds. And so this is my average of my sample. And that number has meaning. We can kind of say it kind of represents this sample. When we talk about this group of people in the weight loss study, I can say their weight's about this. Now, how good that estimate is for this population will matter on a lot of other factors. But that is what a mean does. It has a way of talking about a grouping of data, and it gives one number to describe this. Now, how good that description is will be a lot of the work that we do. But it is a measure of the middle. All right, one of the other ways we have of measuring the middle is the median. And so the median on the same group of data is going to split 50% of the data ahead and 50% of the data behind the median value. And so what I'm going to do is I'm going to take the same weights and I'm going to put them in order. So if you look at that, let's see, our smallest one was 223. Our next one was 235. Oh, we have another 235 in there. Remember, look at the examples in the book. I can't always jump back and forth between the data on the screen. Then 268, 274, 285, and 290. And now I need to find the thing in the middle. And there's 7 pieces of data. So to get a middle, what I want to do is, well, 7 divided by 2 is 3.5. And so I'm going to have 3 things on that side and 3 things on that side. And there's my median. 268 is the median. It's the number that comes in the middle. And so this is another way of talking about the data. And it says that 268 is the median. And so if I have an average of, what was my average again, 258.5, this is slightly bigger. And what that tells me is the smaller values are much smaller than the larger values are from the middle. And this is going to start telling us where our data is. And so our average is 258, or our mean is 258.6, and our median is 268. And so this gives us an idea of what the middles are. And then the last thing to find is the mode. And in this case, we want to look for the value that's repeated the most. And just visually looking at this, 235 is the most repeated value. And so this gives us a lot of information about this data. It says that, we can represent the entire set by 258.6. Talks about that being the mean. 50% of the people are below 268 and 50% are above. And the value that is repeated the most is 235. Now, if there is no value that's repeated the most, then that value has no mode, or that data set has no mode. Now, what this does for us is this will start hinting at the shape of our data. And so all 3 measures can have different uses. And so the mean takes into account every piece of data. And so that's its advantage. The plus side of the mean is it takes in every piece of data. Its disadvantage, or its negative, is if I have an outlier, some piece of data that's really far off, it can do what we call skew the mean. So for example, in those weights that I had before, come up here, and let's say this wasn't 223, but it was someone who was 174. That comes through and it's going to pull the average down even further because it's a smaller number. In fact, if I go back up and recalculate the average with 174 in there instead of 223, so I'll re-add these up really quick. 268 plus 274 plus 285 plus 290 divided by 7. That brings the average down to 251.6. And so it drops the average down. And that's what we mean by an outlier, because most of the other stuff is here. It's near the same place, but 174 is much further down, and it pulls the overall value down. And so that's what we mean by an outlier. And so outliers skew the mean. They can pull it down. And so means are sensitive to that. And we'll develop ways of dealing with it. The median is nice for, it can be affected by outliers in a different way. It can kind of show us where the true middle ground is. An interesting way to see this is if we look at people's salaries, the median salary versus the average salary, because there's people that make a lot of money, they'll push up the average salary. But the median says where 50% of the people are on either. And so we sometimes have to compare the two things together. Now, what can happen with data on mean median mode is it can determine the shape of our data set. And so let me go through and look at some graphs here for this so that we can get an idea of the shape and how mean, median, and mode relate to it. So again, I'm going to pull up the slides here, and here we have the shape of a distribution. And so what we get here is what's called a symmetric distribution. There's equal things on either side. And what ends up happening is the mean, median, and the mode are exactly the same. Notice all of the data fits within this central bin. The most data fits in the central bin. The largest histogram block is in the mode. The median, 50% is above, and 50% is below. And the mean, the average, falls into there. And so a systematic distribution, these values are the same. And we're actually going to say they're going to be close to the same. And so when we measure mean, median, and mode as numbers, if the numbers come out really, really close, we tend to get this shape. And this shape is going to be very important to us. It's going to help us define things. And so we call this a symmetric distribution. If the values are the same for every bin, we call this a uniform distribution. Now the mean and median are the same. It is symmetric, but it has no mode because no particular bin has more than any other. If a tail forms, if there's some tail on the graph and it's on the left-hand side, it's called skewed left, or negatively skewed because the negative side of the graphs are to the left. And what happens is the mean is going to be less than the median and less than the mode, but the mean is less than the median. So if we make these numbers, they tell us what's happening with the distribution. And so if the mean is less than the median, we get a skewing to the left. And then we can have a skewed to the right, and that says that there's a long tail out to the right, or positively skewed. And that means that the median is less than the mean. The median is less than the mean. And so when we attach these numbers, they tell us where our data is. And that helps us kind of determine what this stuff means. And a lot of what we do is, where is my stuff? All right, I'm going to pause this here, and I'm going to do another video on weighted means, because weighted means are actually an important thing that we use. But now we kind of have these visualizations and these geometric tools for figuring out where our data goes. And we have some numbers to attach to things. We have a mean, median, and mode. And we can compare means and medians to figure out what our distributions look like.